Today, same channel, same different experiment. Uh, Today edition. In my previous video, I this is my starter generator. I modify with a high number of tons. Uh, it is a copper, and I make use of the size of the conductor wire is 0. 0.6, as I tested it previously. So if you watch my previous video, you will see it. So it is 0.6 mm. Give me around 308 it's 1 volt. Yeah, 381 volts when I run it with my 12-volt DC motor, brush motor. So I see it, and my alignment, I did it in the instant that when the motor rotates clockwise, the shaft will engage. When it rotates anti-clockwise, it will disengage, like changing the terminal. It act like a crush. So, but this one is different. This one, when I want to pull the motor out or the generator out, I have to, you can see the screw here. So I have to uh, loose it or tight it before it will. So you can see it. You can see it. I have to tight it, or I have to tight it from here or lose it. So for me to pull this motor, apart from the generator shaft, I have to lose this. So I have to lose it. But in my previous video, did it in the when the motor rotates clockwise, it will disengage and engage, disengage, engage. No need of using screwdriver to tighten anything. So it will engage and disengage when you run clockwise or anti-clockwise. So you can see it. It is the same direct drive. The same direct drive. Yeah, it is the same. They are facing opposite. So today, additional, I want to experiment because if we check here, this is a brush motor. It is a 36 volts. So you can see the speed. Yes, scratch away, but you can manage to see 2750 RPM, 27 2750 RPM. But on 36 volt, it run more than that. It run more than that. I think it run uh, around 3000 plus. So on 36 volt, it run more than that. If you check my previous video, you will see where I tested it with a tachometer. On 12 volts, it run on 1000, I think 200. On 24 volt, it run on 2000, I think 200. Then on 36 volt, it run on 3000, I think 300 or 400. So on 36 volt, it run more than this rabbit here. This more than 2750 RPM. So on 3000 RPM, it run more than that. Run on more than that. So it is a brush motor, but high volt. So my previous video I did, it is 12 volt. So I use a 12 volt, but this one is it is very, it can run on 12 volt, 24, 36. So if you look at here, I have three batteries here. Sorry, three batteries here. Each of them is 12 volt, 7 amp. You see, 12 volt, 7 amp. So I have to connect it in series. I have to connect it in series so that it will give me uh, 36 volts. So okay, so let me do the connection one after the other. So okay, so I have some pieces of wire here. I have some pieces of wire here. Okay, now, so Um, First of all, let me test the battery voltage. Let me test battery voltage. Okay, let me on my meter. So to make sure that the battery is fully charged. Okay, 13.08 volts. 13.06 volts. 13.07. So which means that all the battery is fully charged. So all the battery is fully charged. Okay, now I have to make my connection, so that I have to do it in series, make the connection in series. So connect it. Okay, now I have connected in series. So now let me um check it. So the voltage here has already surpassed 20 volts. So no need of putting it on 20 volt again. So I have to shift it on 200 volts. So now let me let me check it again. Can see 39.6 volts. So now let me change the terminal here. Let me change the terminal of the meter. So I have now plugged the negative terminal, black terminal, to the positive of the battery. It will read the voltage. But you see this minus here. This minus means that you have already changed the polarity. So when you show this minus here, which means you have to turn the terminal. So you can see. So this plus sign here show that you have already changed the terminal. So it is not supposed to be. You can see. So this minus. So now, because the LED terminal, which is positive, pointing, is connected to negative. So that's why there is this signal here. Okay, let me change it, connect it normal now, so that you find out that it won't show again. It won't show again. It won't display again. Okay, you can see there's no any signal again because I have connected the right way. Okay, now I have connected the battery in series. So now this is the generator. Remember, this generator I've already modified it with high tones, and I use 0.6 mm copper enamel wire. So now what I have here is two capacitor. I will experiment with the two capacitor. One is 15 UF, the other one is 24 UF. So like I have stated previously, if you want to read the capacitor value with maybe the uh, the number has scratched away, like this one is it's very hard for you to see it. So it is 15 UF, so it has scratched away. It is very simple. If you have a multimeter, so what you have to do is to change your terminal port change it. So what you have to do is shift your meter down to this side, then unplug plug it, connect it on this 20 amp, then you're good to go. Then you can read your capacitor. And when you want to read your capacitor, make sure that you discharge the capacitor to avoid uh, affecting the electronics inside, the IC inside. So you have to discharge the capacitor to make sure that it is empty. So you can see the terminal to read capacitor value. So I have done it in my previous video. So this is a 15 UF. This is 24 UF microfarad capacitor. So I have to test it on this generator. So now I have to connect my meter. I have to connect my meter. I have to connect my meter. So let me put it on AC. So let me put it on AC. Now let me connect it to the output terminal of the generator. Output terminal of the generator. So I have connected the meter to the terminal of the output terminal of the generator. So you can see it. So first of all, let me connect this 15 UF capacitor. Let me connect it. This is the terminal, the capacitor terminal. So I have to connect it on this capacitor. It's supposed to have a clip here, but let me connect it that way. So now I have already connect the 15 UF to the generator now. So I'm gonna let me connect from the motor side. Sharp again. So now, oh, it's already connect. So you can see, I have set the my voltmeter. The maximum voltage the meter can read from AC is 700 volt. So now, what I will now I will have to connect. I will start from 12 volt, 24 volt, 36 volt, so that on 12 volt, let me see what the generator will give me with 15 UF microfarad capacitor. So let's monitor and see. On 12 volt, 16 volt, 15 volt, 17 volt. Okay, let's go for 24 volt. 24 volt, 294, 294. Okay, now let's go to 36 volts. Oh my God, it is more than 700. So that's why this meter couldn't. uh, read it. So let me try it again. 24, 12 volts, 16. The voltage is more than 700. You can see. Voltage is more than 700. So let me stop to avoid damaging my meter. So you can see the voltage is more than 700. The voltage is more than 700. Let me carry out the experiment for the last time again. 12 volts. Motor is running slower. 17 volts. Then let me go for 24 volts. Now I have 208. It drop a bit. So now let me go for 36 volts. So it's more than 700. It's more than 700 volts. So now let me uh, disconnect the capacitor. This A15 capacitor, 15 UF capacitor. Then I will connect it 24 UF capacitor. Okay, I have connect the 24 UF capacitor to the generator. Okay, remember on 12 volts, this capacitor give us, I think, roughly 17 volts. On 24, 290, 280 thereabout. Then on 36, so it couldn't display because the voltage is more than 700. The voltage is more than 700. So this is 1000, but it is DC. So putting it here, we damage the meter. So let me put it at 700 for AC. Okay, so now let's carry out the experiment on 24 UF capacitor. First of all, let's connect from 12 volts. Okay, we have 18, 19 volts, 18, 19 volts. Then let's go for 24 volts. Then we have already 300 on 24 volts. On 24 volts, we have 300, more than 300. Okay, let's go for 36 volts. Let's see what will happen. Same thing happened. Okay, you see. So the voltage surpass 700. That's why the voltage surpass uh, 700 volts. So that's why. Let me let me carry out the experiment for the last time. On 12 volts, the motor is running slower, slower, running slower, slower. My alignment is one of the I try to do perfect and see the between the generator and the motor, both of them face toward each other. Okay. So with 12 volts, we have about 17 to 18 volts. Now let's go for 24 volts. So 24 volts, 326, 27 volts. Then let's go for a volt again to see. Okay, 500 volts. You see, high volts. So the voltage is more than. Let me stop carrying so to avoid damaging my meter. So the volt is more than 700 volts. So because the speed of the motor is a bit higher, so putting more higher value capacitor will still give me high volt. Maybe it may be clocking 1000 volts from the generator due to the high turns about 102, 102 per each slot. So I just leave it on 12 volts. Just leave it on 12 volts. So you can see, just leave it on 12 volts. So 327 volts. So which is very hot. Which is very hot. So let me pull it out. So the reason why it didn't display the full volt here from the generator is because the voltage has surpassed 700. The voltage has surpassed 700, so it won't read it. That's why it display high volt. So leaving it long, we damage this my meter. We damage this meter. So you guys have seen that with high turns, we have high voltage, and which is not suitable putting any load because it will get it burn. Um, this coil here is unmodified like I showed previously, and let me read the resistance ohms. Let me read the resistance ohms. Resistance ohms. Okay, from the generator. Let me. Okay. So now let me read the ohms of the unmodified generator. So now let me read it. I have to switch my meter on. Then let me shift it a bit. Then let me reverse it. You see it will be pointing towards this diode sign. So then when you touch your two terminal, you have to make some sound. So you have to make some sound. You have to make some sound. Okay, now I see. So now let me read the ohms resistance of the unmodified. Let me shift it a bit. So 12 ohms. So now let me lead my modified generator. Let me read my modified generator. So you can see 25 ohms resistance. 5 ohm resistance. So it's like it's like
double of this coil. So it's like a triple, mean double. So it's like winding this coil, the total tons times two. So this one gave me 12 ohms. This one gave me 30, I mean 25 ohms. It varies. Sometimes it will show 26. So you know how it works. So uh, like winding this double times two, winding the coil, because like I said previously, this coil, when you lose it, maybe starting from 40, 40, 45 or 50 that's what usually they wind. Understand? That's why when you use a motor that is running maybe 27 rpm, 2700 rpm, maybe you're getting something about uh 250, 28, I mean 150, 180, or maybe 200 volts. And if you decide to put a higher capacitor, maybe something about 30 uf or 40 uf or 50 uf, it will create a lot of drag. It will create a lot of drag, which the motor will be consuming a lot of current. So that's why I said that all the whole system is maintained. So you have to put much turn, you have to put the turns, calculate it, calculate the exciter, so that at least everything will be made. Because when you put much capacitor for you to generate more high volts, it will induce a lot of magnetic field in the armature, which in turn the magnetic field will be so hard, like using a powerful magnet. So it will be hard for the motor to move it around this stator, because the heavier, the more attractive it is, the heavier it's for the motor to rotate it, because you know this thing is iron, and you know iron and magnet attract, iron and magnet attract. So everything have to be calculated. uh, don't put much like this one now. It is not recommended for this project, because the voltage is more than 700. So that's why it didn't display here, but you can see it's going from 300, 400, 500, and it's give me a signal here that the voltage is high. So so that is the issue with this coil. So it is, like I stated previously, it is suitable for windmill, hydroelectricity, um, or windmill, which do not need much speed, then it will give electricity. So I would have run this to know how many voltage it will give me, but there's not much doing it. There's not much doing it. So with higher speed, maybe it will give me something about two something, because the speed of this motor is more than the previous one I tested. So initially they write 2,750 RPM, but I tested previous, it run more than that. It run more than that. So that is the experiment of today. So I've carried out with the different motor. So I'm doing the experiment and observing a lot of things. So if you have a question, feel free to ask. So the previous design is disengage, engage. So this one is before you remove it, you have to lose it from there. To remove it, pull it, yeah, lose it before you remove the generator. Thank you for watching.